Hello everyone, happy to see you here. Welcome back to my channel Hi Mathematics. Today we have great algebra question k to the power 4 plus 4 equal to 0. We need to solve this question for k. So write your solution, write your assumption, write your notes in the comment below, and then we will check our answers. Okay, so let's start. How can we solve this type of question? First of all, let's rewrite it and let's start to solve it. So k to the power 4 plus 4 equal to 0. Right now I'm going to show you one really interesting trick. How can we solve this question? Just look at it closely. So we have k to the power 4 plus 4, and right now I'm going to add to this expression 4k squared, and of course we need to subtract to it, so minus 4k squared equal to 0. So basically it changes absolutely nothing. So this expression right here, what we add exactly to this one, equal to 0. So basically it changed nothing. But right now let's try to regroup all the things. So let's regroup it. So we have k to the power 4. The next thing we write plus 4k squared plus 4 and minus 4k squared. Right here we can easily write in parentheses equal to 0. Okay, so I hope you understand. We just do this tricky move. Right now, what do we have in parentheses? We have k to the 4 plus 4k squared and plus 4. And right now, let's look closely at this expression. So I'm going to write it on the left side. So this is not our solution. I just want to raise k squared plus 2 to the power 2. So I just want to raise it. So what do we have as a result? k to the power 2 raised to the power 2 plus 2 times k squared and plus 2 squared, so plus 4. So if you look closely, k to the power 2 raised to the power 2 equal to k to the power 4 plus 4k squared plus 4k squared and plus 4. Exactly the same expression that we have in parentheses. So this expression in parentheses we can easily change, we can easily swap with this one, k squared plus 2 to the second power. So let's do it. So we have k squared, this is our expression, k squared plus 2 to the second power and minus 4k squared, minus this one, 4k squared. So I hope you understand it. And of course equal to 0. Right now we have, for example, this is our a. We have a squared, this is our parenthesis square, and right here let's write this 4k squared as so let's write it in this way. So we have k squared plus 2. So what I mean right now, this expression right here, for example, this is our a, and let's write this one in the same way. So let's write it as some parentheses raised to the power 2. So we can write it as 2k raised to the power 2 equal to 0. Okay, so I hope you understand what I mean. So I just want to make this expression when we have difference of squares, when we have this classic school identity. And right now let's expand it in terms of this school identity. We know that a square minus b square equal to a minus b, or a plus b at first. So a plus b times a minus b, a minus b. Okay, really great. And right now let's expand this expression in terms of this formula. So we have k squared plus 2 and plus 2k, and we have the second one, k squared plus 2 and minus 2k equal to 0. So right now we have a product of two parentheses, and a product of two parentheses equal to 0 when the first parenthesis equal to 0. So we have we're gonna split it. So we have the first parenthesis, so k squared plus 2k. I'm gonna write this 2k on the second position, so plus 2k and plus 2 is equal to 0, or the second parenthesis, k squared minus 2k and plus 2 is equal to 0. So right now let's solve these both equations. Let's start, for example, with this one. So we know every coefficient right here. So a equal to 1, b equal to 2, and c equal to 2. So let's solve, for example, for discriminant equal to b squared minus 4ac equal to b squared. So 2 squared minus 4 times 1 and times c, so times times 2. So our discriminant is equal to 4 minus 8, so equal to minus 4. So right now let's plug in this discriminant to like all known formula. Everyone knows about this formula, so we have k first and second equal to minus b plus minus square root of discriminant and all over to a. So let's plug in. We know absolutely everything. We know each of these coefficients. So we have minus b minus 2 plus minus square root of discriminant square root of minus 4 and all over to a, all over 2 times 1. So right now let's simplify real quick our expression right here. So we have minus 2 plus minus this square root of minus 4 we can write as square root of minus 1 times square root of 4. Yeah, we can write it like that, all over 2. So our final answer, we can write it as minus 2 plus minus 2i, because square root of 4 equal to 2, so we have 2i, and square root of minus 1, this is our imaginary unit, this is our i, and all over 2. So in this branch, when we divide this by 2, each of these coefficients, so we have minus 1 plus minus I. So we can write that our k first equal to minus 1 plus I, and our k second equal to minus 1 minus I. These are our two roots, and right now let's go back to the beginning. Let's solve our second branch. So right here we have our second branch. Let's write our coefficient a equal to 1, b equal to minus 2, and c equal to 2. So what do we have in this case? We have absolutely the same discriminant, so b squared minus 4ac equal to b squared, so minus 2 squared minus 4 times 1 and times 2. So in this case we have 4 minus 8, so the same discriminant equal to minus 4. So we exactly have like two complex roots, so we have k second and k third equal to minus b plus minus square root of discriminant and all over to a. So we have minus b minus 2 plus minus square root of discriminant square root of minus 4 and all over to a 2 times 1 equal to minus 2 equal to 2 plus minus, and the same thing with this square root of minus 4. So we can write this expression as according to this way. We can write it as square root of minus 1 times 4 equal to 2i, so 2 plus minus 2i all over 2. We're gonna cancel this 2 from here, and as a result of our final answer 1 plus minus I. So let's gather all the roots together right here. So for example on the right side, so our answer to this question, so k first I'm gonna rewrite from here minus 1 plus I, k second equal to minus 1 minus I, k third equal to 1 plus I, and k fourth equal to 1 minus I. So all these roots, all these four roots are complex roots, and none of these are real. As you can see, we have I in every cases, and yeah, this is our solution to this question. I really hope you understand it. Of course you can easily check it, but I think that we don't need to check these complex roots. For example, if we have like a real number root, we can check it, but in this case we don't need to check this because we're gonna raise this to the power 4. It will be like a long video. This is a correct answer, you can trust me, but if you have a different answer, you can also write your way, your approach in the comment below. It will be really interesting to read about it. And exactly in this case, when we have k to the power 4 plus 4 equal to 0, so we can write k to the power 4 equal to minus 4. So exactly in this moment you can easily see that our roots will be complex roots because we have an even power and we have a negative value. So it means that our roots will be complex. So each of these, all these roots are complex roots. Of course, write your thoughts, write your response in the comments below. What do you think about my solution? We just did this tricky move right here, and we factor it. So exactly in this moment we have a product of two parentheses. So maybe until this moment you have your way, how you see a solution, how you see this factoring. Write your notes, write your approach in the comments below. It will be really interesting to read about. about it. And of course, it's really interesting to exchange information because there are a lot of teachers, a lot of students here. That's why it's extremely great to see how do you see a solution, to see your feedback. It's great for everyone. So I want to say thank you for watching. Thank you for being here. Don't forget to write your respond, and of course write. Maybe you solved this question with me. So write your write about your answer. If our answer if our answers are similar or not. It's really great to see it, to see your feedback. So thank you everyone for your time. Take care of yourself. Have a great day, and see you in the next videos.